everybody. So we've already reviewed factoring, so I want to talk about how we are going to use factoring. So the first thing we want to talk about is what is a quadratic function, and then what is a quadratic equation. Okay, so a quadratic function is any function where the largest exponent of the variable is 2. Okay, so we might be talking about something like f of x equals x squared. Okay, we could be talking about something like 2x squared plus 3x minus 1. Okay, or we could be talking about something like x minus x squared. Okay, so any of these things are quadratic functions, okay, because, oops, not this one, that's supposed to be a 2, because the largest exponent needs to be a 2, okay? So we are looking at anything that has x squared as its largest exponent. Okay, then what is a quadratic equation? Okay, so again, quadratic refers to the highest exponent of the variable being 2, okay? And now we are looking at an equation that has that property, okay? So let's talk about how to solve a quadratic equation using factoring. Okay, now that we've reviewed all of the different methods of factoring, let's talk about how we are going to use them. Okay, so our plan is to move all of the terms to one side. Okay. Okay, so we're going to put our equation into standard form, which is going to look like ax squared plus bx plus c equals 0. Okay, so we have all the terms on one side going from biggest exponent to smallest exponent, okay, and 0 being the other side. Okay, then we are going to factor completely. Set each factor equal to 0. Okay, and then we are going to finish solving. Okay, so let's look at some examples of solving this way. Okay, what types of equations can be solved this way? Okay, so we can see that this is already in the standard form where we have all of our terms on the left and 0 on the right, and the terms are going from largest to smallest, right? So x squared, x, and then our constant term, that's just the number. Okay, so we're going to go ahead and factor this. So we are going to factor by guess and check. Now, I already know what the factors are, but I recommend that you go ahead and factor this yourself to make sure you remember how to factor with guess and check. Okay. So if I'm looking for things that factor or that multiply to 12x squared, I could be doing 1 and 12, 2 and 6 like I have here, or 4 and 3. Okay. Then I'm looking for numbers here and here, right? The second numbers in each term that factor or that multiply to negative 15. So like I said, I know that this is negative 3 and positive 5. Okay, so if you forgot how to factor stuff like that, go back and review factoring by guess and check. Okay, then I have my two factors. I'm going to set each of them equal to 0. Okay, and then I'm going to finish solving. So here I'm going to add 3 to both sides and divide by 2. Okay, and over here I'm going to subtract 5 from both sides and divide by 6. Okay, so we have two different solutions here. Unlike with a linear equation where we saw that we only had one solution usually, there are a lot of times with quadratics, most of the time, you will have two solutions. Okay, let's go ahead and look at another example. Okay, now we can tell that this example is definitely not in the standard form. So the first thing I'm going to do is change this into that standard form. So I'm going to write this side out as t minus 3, t minus 3. Okay, and then on this side, I'm going to distribute. So 3 times 9 is 27. 3 times negative t is negative 3t. Okay, and then I'm going to multiply it out on this side. So t times t is t squared. T times negative 3 is negative 3t. Negative 3 times t is negative 3t. And negative 3 times negative 3 is positive 9. Okay, and then I'm just going to leave my right side alone. Okay, now that I have everything distributed out, I'm going to move everything to the left. So I still have my t squared. Now I have negative 3t, negative 3t, and I'm going to add 3t to both sides to get rid of this 3t on the right. Okay, so that's going to leave me with negative 3t on the left and no t's on the right. Okay, and then I'm going to subtract 27 from both sides, so 9 minus 27 is negative 18. Okay, so now I'm in that standard form where I have everything on the left, okay, and just a 0 on the right. So now I'm looking to factor This is the normal type of factoring, the what multiplies to this and adds to that type of factoring. So I'm looking for something that multiplies to negative 3 and adds, or sorry, multiplies to negative 18 and adds to negative 3. So that should be negative 6 and positive 3. Okay, set each of my factors equal to 0. Okay, and then get my solutions by solving these. So add 6 to both sides and get one solution as t equals 6, and subtract 3 from both sides here and get my other solution, t equals negative 3. Okay, so this is really how you solve by factoring. So there's one more type of example that I want to talk about here. Okay, so we are going to look at a quadratic function, and we're going to ask ourselves, find the x-intercepts. Okay? All right. Now, we know that in general, to find the x-intercepts, we talked about this with linear functions, to find the x-intercepts, we let y equal 0. Okay, so this is no different for quadratics. So I'm going to let y equal 0. Okay, and then I'm going to solve this equation by factoring. So I am looking for two numbers that multiply to positive 15 and add to negative 8. So I think it should be negative 5 and negative 3. Set each of my factors equal to 0. Okay, and solve each one of these. So I'm going to add 5 to both sides, and I'm going to add 3 to both sides. Okay, so here I have my two solutions. Now remember, when we're talking about intercepts, these are ordered xy pairs. So for this first one, my x-coordinate is 5, and my y-coordinate is 0. Remember, that's true for both of these. We let y be equal to 0 to start. So for my second x-intercept, I have x equals 3, and again, my y-coordinate is 0. Okay, so I want to point out the relationship here between the factors x minus 5, x minus 3, and the x-intercepts, right? 5, 0, and 3, 0. You can see that there's a direct correspondence between the factor x minus 5, the solution x equals 5, and the x-intercept 5, 0. Okay, and the same with this factor. There's a direct correspondence between the factor itself, x minus 3, the solution x equals 3, and the x-intercept 3, 0. Okay? All right. So now we've talked about solving quadratic equations using factoring. We've talked about applying that to x-intercepts, and I will see you guys in class.